Today we're going to start solving quadratic equations, and there's several methods for solving quadratic equations. The first one we're going to study is graphing. So at the top of your notes it says a quadratic equation can be written in standard form as ax squared plus bx plus c equals 0, and it does need to be equal to 0 before you start your solving process. You can solve the quadratic equations by a variety of methods. Our first method for solving a quadratic equation, ax squared plus bx equals 0, notice there's that equal sign, is to graph the related quadratic function y equals ax squared plus bx plus c. So our previous lessons, we were working with just the function, and now we're going to solve equations by graphing that related function. Our solutions, also called zeros and roots, we've been using these vocabulary terms lately, of our equation are going to be the x-intercepts of our related function. Off to the side, you can see some examples of when there are two x-intercepts. You can see the parabola is crossing at two places, and this is going to happen most of the time. Our parabola is going to cross our x-axis twice, or remember, it could also be reflected over and be like a frowny face and still crossing x-axis twice. It could just touch the x-axis at one place, and we could have one solution or one x-intercept. And then we could also have no solutions, and that's just where my parabola is too high, or if it's a frowny face, it's too low and it's not crossing the x-axis at all. So let's start with number one. We're going to graph the equation y equals negative x squared plus 8x minus 15 on the axes. And again, we're going to plot 5 points that include our roots and our vertex. And then we're going to use that graph to determine the roots of the equation negative x squared plus 8x minus 15 equals 0. So let's start by graphing. Just to review, let's start with our axis of symmetry. Remember that formula is x equals negative b over 2a. In our formula up here, my a value is a negative 1, b is 8, and c is negative 15. So when I plug this into the formula, we're going to have a negative 8 over 2 times negative 1, or negative 8 over negative 2, which is going to give me positive 4. My axis of symmetry is at positive 4. I'm going to go ahead and put that dashed line at negative 4. I'm going to go ahead and find my vertex. You plug in that positive 4 that we just found for our axis of symmetry into our equation y equals negative x squared plus 8x minus 15. So let's plug in the 4 here. We're going to have negative, and then just the 4 is getting squared. So we have negative 16 plus 32 minus 15. If you simplify that, you are going to get a positive 1. So our vertex is 4, 1. And then just to review as well, because our parabola has a negative in front, I know it is a frowny face. And then its leading coefficient is negative 1. So I could use the 1, 3, 5 rule to help me graph. So from your vertex, 1, 3, 5 means you would go over to, say, the right 1, down 1. Over 1, down 1, 2, 3, over 1, 1, 2, 3, 4, 5. And then you can reflect from there to give you the rest of your parabola. Now, I'm going to grab the calculator, of course, and let's graph it. Remember, our goal is to then identify those x-intercepts, which we're already starting to see on my graph. All right, so on my calculator, I'm going to do a new page. I'm going to graph this beautiful function. We've got y equals negative x squared plus 8x minus 15. And enter. You can see that. Let me turn on my grid lines. Let me also let's do menu trace, and let's graph trace, and we can slide this left and right. Let's go back up here to where our roots are. There's one of my zeros, and it's labeled down here at the bottom 3, 0. There's my maximum or my vertex at 4, 1 that we found, and then my other 0 at 5, 0. So let's connect our points on our parabola, and those were the points that we found using graph trace Our maximum or our vertex was at 4, 1, and then we had roots at 5, 0, and 3, 0. Your question was use the graph to determine the roots of the equation negative x squared plus 8x minus 15 equals 0. Those roots are 3 and 5, those x values of your x-intercepts. 3 and 5, and done. That was the whole purpose. So we graphed the function so we could physically see where it crosses the x-axis or physically where it's equal to 0. Where it hits the x-axis, those y values were 0, right? So at 3, when x is 3, the entire equation would equal 0. When the x value is 5, the entire equation would simplify and equal 0. So 3 and 5 are our roots. Or they could have also said, hey, find the solutions to this equation. They're still talking about those x-intercepts. So roots, solutions, x-intercepts, or zeros. So lots of vocabulary there that all means the same thing. Let's look at number 2. All right, number 2, graph the equation y equals x squared plus 6x plus 5 on the axes. Plot 5 points, including the roots and the vertex. Use that graph to determine the roots of the equation x squared plus 6x plus 5 equals 0. So we're going to do the same thing. I'm going to walk through all of our steps graphing by hand. So axis of symmetry. That formula is x equals negative b over 2a. And guys, remember, sometimes we might have questions on benchmarks in our non-calculator section where we'll need some of this information. So do practice finding your axis of symmetry by hand. Don't rely 100% on the calculator all the time because we might have non-calculator questions, like I said. On number 2 here, our function, our a value is a 1, b value is a 6, and c is 5. So when I plug it into negative b, that's a negative 6 over 2 times 1, or that's going to simplify to negative 6 over 2, or a negative 3. So let me go ahead and dash that negative 3 axis of symmetry on our graph. To find our vertex, we're going to plug that in to y equals x squared plus 6x plus 5. So plugging in negative 3, all of negative 3 is going to get squared. 6 times negative 3 and then plus 5. So we'll have 9 minus 18 plus 5, which is going to simplify to a negative 4. So our vertex, negative 3, negative 4. So at negative 3 going down to negative 4, there's our vertex. Now again, my leading coefficient was at understood 1, right? So I know we've got a positive smiley face, and I know I could use the 1, 3, 5 rule to help me graph. So from my vertex, I'm going to go over 1, up 1, over 1, up 1, 2, 3, over 1, 1, 2, 3, 4, 5. I'm going to reflect those points. And that should be my parabola. Again, I'm going to grab the calculator and we're going to graph it and double check. And again, we are looking for the roots or those x-intercepts, those zeros on the calculator to solve the equation. All right, I'm going to do Control I to insert a new page. It's going to give me a new tab at the top, and we're going to add graphs. I'm going to type in y equals. We've got x squared plus 6x plus 5. I'm going to graph it. I'm going to do all those same things. We're going to turn on our lined grid. I'm going to do trace, graph trace. And let's slide to the left here. Let's see. R0, we've got a negative 1, 0. I plotted that already. Our minimum, which is our vertex, negative 3, negative 4, we got that as well. And then I slide over to this 0, negative 5, 0. So I've got all of those. Let me connect those points to make my parabola on my graph. All right, those roots, those x-intercepts, we said they were negative 5, 0, and negative 1, 0. We're just using that x value. Where the entire function, where the entire equation would be equal to 0 is at negative 5 and negative 1. All right, so there is your first method for solving quadratic equations. When we get ready to take our end of course test, there's going to be tons of quadratic equations, and you're going to have the choice of which method you would like to use to solve. We're going to learn about 5 or 6 different methods. Now, graphing is not the most convenient. If I don't have a calculator in my pocket, or if I don't have graph paper in my pocket. So there's some other algebraic ways of solving that we're going to see, but we do see a lot of graph questions on our end of course. And so being able to analyze your parabola and knowing that those x-intercepts represent solutions to your quadratic equations can help you solve problems. So I hope this has been a good review of just graphing. We graphed just a couple of lessons ago. So still utilize those calculators. We are looking for those roots, which are called zeros. They are our x-intercepts, and they are the solutions to these quadratic equations. Let me know if you have questions, guys. Have a great day. I'll see you in class.